Now, as we go on to our third section in Unit 2, we skip 2.3, although we sometimes call 2.4 2.3, but keep in mind it's the lesson that deals with exponents and log functions and is the third lesson. Now, as we look at our first example, you'll write this up in your booklet. I'm going to make two graphs here. And this question deals with the general shape of these graphs. In this first case, we're saying that our base A is going to be greater than 1. So an example of this was, let's say, 2 to the x power. And in this second graph, they're saying that it's greater than 0 but less than 1. So this would be a fraction. So our base here to the x power, an example would be 1/2. Now, what were the shapes of these graphs in general from our flipped classroom video? Well, we said, keep in mind they always go through 1 when we make our little t-chart. And if it was a number greater than 1, the general shape was that it started low and then it went up like so. But if it were a fraction, it would start high, again going through 1, and would then go low as you go to the left. And that's what they're asking on this first question. So take a moment, sketch this in your notes. Now for number 2, we have the square root of 3 raised to the power of the square root of 6. So how would you put that into your calculator? Well, put the square root of 3 and then use the caret. And then the idea of putting this in a parenthesis would never hurt. The square root of 6 and hit enter. And let's see what you get. Well, 3.84018. And they want us to round to 4 decimal places. So 1, 2, 3, 4. Our fifth is an 8. So we're going to drop the 8 and add 1 there. So the answer to this one is this. All right, this was just a challenge to put it into your calculator correctly. All right, let's go on. Now for number 3, we have this function. Now it's a whole number, so which graph do you think would reflect this? And this relates to example 1. And if you chose the letter C, that is correct. Now, what kind of graph is A? And again, I'm asking questions that I know the answer to, and you may be wondering, but since it's a straight line, this is linear. And this, again, looking ahead, is a graph of what kind of function? Well, this is for a log of something. It's probably this in its logarithmic form because it looks like the sister of this one. But where this is the exponential form, this would be the logarithmic form. And does anyone know the name of this type of graph as we see in letter D? And you could put some notes down here if you want to sketch them all. This is a parabola. Okay, let's go on. Now for number 4, we're asked to use our calculator again and find Euler's E and raise it to the 8th power. So in some calculators, they already have the caret built in. In my TI-84 that I'm using, I have to put the caret there, 8, and let's see what you get. Well, 2980, and we want it to 4 decimal places, 95798. So again, there are 4 decimal places. Since this is an 8, we're going to make this decimal portion 95. Adding 1 here makes this an 80. And then just bring in this part. And that's our answer. Now, if you only put 3 decimal places as an answer, they are asking for 4. So be sure you include the 0. Now, for number 5, they give us an example that's in exponential form, as we see here. Now, this is an example in exponential form that we did in our flipped classroom lesson. We have our base to an exponent gives you the answer. And we said that was equivalent to log form, where log is an exponent. So we have log base 2, the answer is 8, and the exponent is 3. So they're giving you the format to fill in over here. So it'll be log, base is 1/2. What did we say the answer was? 8, and the exponent is -3. Now, interestingly, what I have written here is equivalent to what is written there. Because notice our answer is the same in both cases. But for now, this is all you need. Now, reversing what we had, here this is in log form. Write this in its exponential form. Give you a moment. Well, our base is 2. Our exponent, remember logs, our exponent is 0. And our answer is 1. I'll make a fancy one here for you. And again, converting this into its log form, there we have it. And if you have a question, be sure you're asking. Now for number 7, we're asked to use the compound interest formula to find the future amount. And in the flipped classroom video, we gave you that particular formula. So take a moment to copy this down. Again, this is example 7 in a box. And then take a moment again to substitute this information into the formula. We'll do it together in a sense. The amount is 16,000. 1 is straightforward. Now the rate is going to be an interest rate of 7% that we need to convert to its decimal form. And the period of compounding is semi-annually, which means twice a year. And then we need the time, and it's going to be 5 years. But we also need this n, which is 2 times 5 years. And would you agree that 2 times 5 makes this a 10? So we'll erase that just for ease of computation and put a 10 there. Now, again, figuring this out in your calculator, the suggestion is you go 0.07 divided by 2, add 1, then do caret 10, get a value in your calculator, then multiply it by this, and let's see what you get. And something like this. So here, again, you want to be sure you're familiar with the formula, how to put data into the formula, and then a strategy for working the formula so you end up with the correct answer. And this is pretty good. 7% interest, 5 years, you've made over $6,000. Wow. Now for number 8, here we're asked to do two things and make a comparison. So this would be plan A here, and this will be plan B. So this is compounded quarterly, and this is the continuous interest formula where we use Euler's E. And again, we showed how to do this in our flipped classroom lesson. So take this material, we're going to pause and substitute, and then we'll compare to see results. And let's see if you put your data into the formula correctly. So there's our 42,001 plus our rate is 0.015. When we convert that to its decimal form, quarterly is 4, and it's for 3 years. So 4 times 3, we can convert that to a 12 here to make our calculation a little easier. Just wanted to show you where it came from. And then for continuous interest, we have the 42,000 times Euler's E, and then caret interest rate in decimal form 0.013 times 3. And if you put that all in the calculator, that shouldn't be a problem. Now let's see what the results are when you do this. All right, this one's going to take a little bit of time, no matter how quickly you try to do it. When we put this in there, we get this. When we put this into the calculator, we get this. And we see that plan A, with that little bit of greater percentage, is actually the better deal. So plan A is the better deal. You'd put a little dot there in your computer, and it's when I subtract these, I get it's by $127.90. Wow. So you can see just the slightest little error here will give you some problems. But again, this is the work and this is the results. Now, we did one like this in our flipped classroom video. It involves a little bit of higher mathematics, so follow along as we go over this one. If you get one like this, this is how you would do it. So there is your continuous interest formula. We want to know how long it would take if at 6%, how many years for this principal to triple. So, would you all agree our future amount here is going to be 3p? Okay? Now we're going to do a little bit of fancy algebra. We're going to divide both sides by p here. So this equation, now the p's will cancel out and we get 3 equals e. And then our exponent is 0.06t. And we're going to use natural logs to solve for the letter t, because in a sense, this is in its exponential form. So I believe this is example 3 in your booklet. And an interesting thing happens when we convert this to its natural log form. We say the natural log of 3 on this side, and then the natural log of this. Since the base of the natural log is e, this part here disappears, and this then becomes what the results is. Now, again, there's a little tricky part here, a little higher math. We're going to divide both sides by 0.06. And in your calculator, you put natural log, use that key, 3, and then divide by 0.06. And you get then 18.3, rounding it off to 1 decimal place, years for this principal to triple at 6% interest per year, compounded continuously. Wow. All right, this one is done in a very similar way, and we're dealing with carbon-14 dating. Now, while you are alive, anything alive takes in carbon dioxide, and the amount of radioactive carbon dioxide is, this carbon-14, is in equilibrium with the environment. But once you die, anything that dies, it stops taking in this carbon-14. So the amount of carbon-14 diminishes as time goes on. So if you take a sample from a dead organic matter and you compare it to what we have now, and they give that here in this formula, we can then determine how long ago with this decomposition rate that material was alive. So here they're saying that after a certain number of years, it was 4/7 of what was originally there. And then we have this formula. A sub O is just the 1, so we take E and this exponent. Now what we're going to do is convert this to its natural log form. So we take the natural log, and we would put this in parentheses. And then remember, we said that when we converted this side to its natural log, the E disappeared on this side. Let me erase it here. And that all you were left with now is this. So this is a negative 0.0001216x. Now to solve then for x, we're going to divide both sides by this. So in your calculator, you're going to put natural log, parenthesis, 4 divided by 7, close parenthesis, and then hit divided symbol, and then put this in. Now you have to put negative 0.0001216. Again, this is more of a calculator exercise than bringing up a lot of math and knowing how to do it. And then give this a try and see what you get. And you want to round this to the nearest 100 years. So when I did it, I got 46, rounding it off to 100 years. This material, this mummy in this case, was alive 4,600 years ago. Wow. So carbon-14 dating. Now on our test, we're not going to have anything this complicated or as complicated as the previous example. This is more following the recipe. And again, there's a lot of higher math that we're just surveying at this stage. All right, we'll wrap this up.